Our world is changing. The 20th century focused on technologies like gasoline engines and chemicals to lead us into a modern level of control and influence over our environment. Now, the focus on the 21st century is repairing the damage. Somehow, we must return our land to its natural, healthy state, while also improving the quality of yields we get from agricultural land that is shrinking due to urban expansion. Many believe that more highly refined or even synthetic chemicals are the solution, but in reality, we need to return our environment to its natural state. Instead of more chemicals, we need more understanding. We believe we can make a contribution to the science of ecological health by understanding how nature works, and this is what BEST is all about. Although we continue to do our own research, we also commission projects and studies that are conducted by universities and governments around the world. With this research has come discoveries into the secrets of how life has worked on Earth from the very beginning. Much of the science from the last century has been in trying to understand how a specific part of the Earth's ecosystem works, and we've made many important discoveries. The one thing that we need to remember is that everything in nature is designed to work together, and it all starts in the soil. Healthy soil exhibits these characteristics: loose, well-structured earth which promotes good aeration and percolation. It has a high population of organisms that you can see and millions of microbes that you can't see. Healthy soil has, on average, 600 million microlife per teaspoon. When soil is healthy, these microbes establish a rich environment called the rhizosphere that aids in promoting and maintaining healthy roots. Plants need many nutrients to survive, and most are absorbed by the roots. So the healthier the root system, the healthier the plant. Microbes extract nutrients from the soil, refine them, and store them in their bodies or concentrate them in colonies around the roots where the plants take them up. In return, plants excrete sugar back into the soil for microbes to use. This symbiotic relationship is a natural process and is an advantage to both. Microbes feed the plant and the plant feeds the microbes. There are many forms of life in the soil, and a balanced community is essential for healthy soil. Bacteria are largely responsible for the refinement of nutrients. These organisms eat, store, and release more nitrogen than any other organism known. When they have the right food, moisture, and temperature, they split and divide on average every 20 minutes. As bacteria populations increase, more nutrients are able to be refined and ultimately made available to the plant. Fungi are large tubular-like organisms whose job is to transport the nutrients to where they are needed, at the plant roots. Fungi tubes, called hyphae, are nutrient highways that can extend from a few inches to over 100 feet in length, allowing the nutrients far from the plant to be transported back in exchange for sugar. The interaction of bacteria and fungi is essential to the health of soil, providing the basis of the food supply for all other soil life, and a protection mechanism for the plants from predators within the soil. For instance, grazers and herbivores eat roots, but when a healthy fungal population exists in the root structure, they act to kill these root feeders, which in turn creates food for the fungi and bacteria. Grazers and herbivores are also essential to this environment because their movement through the soil helps to loosen it. Earthworms and other burrowers also live in this environment, creating larger tunnels that aerate and allow water to seep deep into the soil, supplying roots and soil life with much needed moisture, which is stored for future need by other soil life, even in drought conditions. As bacteria refine nutrients, specifically nitrogen, the nematodes and protozoa in turn eat the bacteria. As these predators do not require all this nitrogen, they deposit the excess back into the soil, making it readily available to the plant. These soil microorganisms eventually die or become food for each other, Either way, the now concentrated nutrient deposits become ideal attractors for both hyphae and plant roots. All these organisms are classified as aerobic, meaning they need oxygen to survive. Even though a healthy plant absorbs the majority of the oxygen it needs through the leaves, the roots and microbes also need oxygen. If the soil oxygen level goes down, microbial populations are reduced and the soil begins to ferment. Organisms which do not need oxygen to survive begin to multiply. These anaerobic organisms are, for the most part, pathogens or disease-causing to plants, and yields go down. Even the best current farming practices reduce the number of beneficial soil organisms. Compaction of the soil happens when we take heavy equipment across the land, squashing the homes of the beneficial organisms, reducing the amount of air in the soil, and limiting the soil's ability to absorb water. Tilling damages soil structure and destroys the colonies of microlife. As the fungi's hyphae are broken, the ability to search out and carry nutrients to the plant is also interrupted. When both the colonies of the bacteria and the fungi are disturbed and killed, the entire food web of the soil begins to break down. Most farmers put fertilizers and chemicals into the soil. The most common is inorganic nitrogen. When inorganic nitrogen interacts with existing soil moisture and rain, it dissolves and is attached to the water. The water is then absorbed by the roots, and the suspended nitrogen is inadvertently taken into the plant as well, upsetting its natural balance of nutrients. Since the plant's nitrogen level increases, its need for water also increases, because nitrogen is a salt and salt dehydrates. When inorganic nitrogen is absorbed by the plant along with water, the plant's nutrient level becomes unbalanced. A common side effect of unregulated nitrogen absorption is a tall plant with weak stalks. These large but thin cell walls make the plant susceptible to disease, pests, and even lodging. Excess fertilizer in the soil also becomes an issue. With reduced microbial populations, much of the fertilizer is no longer able to be stored and leaches through the soil, entering and contaminating the water table. Just as humans need to both eat and drink, plants remain healthy by controlling the intake of water and by absorbing specific nutrients on demand as roots interact with soil microbes. A healthy plant has a higher sugar content and thicker cell walls, both of which help insulate and protect it from disease, pests, and environmental stresses. With our understanding of soil life and how plants naturally absorb nutrients, BEST has been able to make products and provide solutions for everyone who grows plants. What happens is revolutionary. The typical farmer uses less fertilizer because soil microbes help convert it into a form more suitable for plant absorption. And since the microbes concentrate the now organic nutrients where the plant can absorb them, there is also a substantial reduction in water contamination. As a result, the plant becomes far more healthy, and the natural predators that would attack the plant are kept in check. So fungicide and pesticide use are significantly reduced. And with healthier plants comes less input costs, frequently bigger yields, and increased profits. Throughout the world, BEST environmental technologies provide solutions to many problems facing the agricultural industry. Not only do we help address soil and plant issues, we also have developed solutions for failing animal health, all from the simple idea of going back to nature. With our knowledge of water structure and composition, we are able to manage or improve the condition of both natural and purified waters. Farming throughout the world has many forms. In North and South America, as well as Australia, the impact that a single farm can have on the environment can be massive, while in some parts of Asia and Africa, the average farm can be very small. Regardless of where you are, Best's natural products and services have been proven over and over again to give the local farmer the advantage they need to become more ecologically responsible and profitable. Our mission is to provide positive environmental products, systems, and technologies that are economically viable for the world. Best Environmental Technologies is a company that is growing very quickly by helping people the world over become more profitable. By understanding and fostering soil health, we can work together to lower the dependency on chemicals and inorganic fertilizer, improving the quality of crops and increasing yields throughout the world.